In 8th grade, section 9.5, we're dealing with scientific notations. So scientific notation is basically, we're using it because a number expresses a product of a factor and a power of 10. So what that means is, we're expressing it a different way because the numbers we're dealing with is either too big or too small. So for example, this number is so big, and this number is so small. So we're going to use scientific notation in order to shorten it up. And what I do is I put the decimal, okay? I put the decimal right behind the first number, so 1.276. This is exactly the same. See 1.276, 1.276, right? And then if the rest are zeros, I don't have to worry about writing it. I just write the actual real numbers, okay? Once I do that, then I see how many times I move the decimal places, and then I do 10 times whatever that is. So for example, here, this is, the decimal point is here because this is all in front of the decimal, right? Because there's no decimal, I'm assuming it's all decimal. None of it is in decimal. So I moved it 1, 2, 3, 4, 5, 6, 7, right? Because it's right behind that 1. So that means if I multiply it by 10 to the power of 7, that means if I actually work this out, it should give me this answer. So I'm not changing the value of the numbers. So it's very important. If you multiply it back out, you get a different number. Something went wrong. In this one, is the same case, 1.276, except I'm going the opposite direction. So if I'm going the opposite direction, my exponent is going to be a negative. And so I put the decimal here, and I need to count how many I need to move it to get to the original number. So 1, 2, 3, 4, 5. So now that's times 10 to the negative 5. Right? So let's try it. This is called standard form, and this is scientific notation. So if they want us to write this in standard form, they want us to write it out just like this. So 3 times 10 to the 5th. So I'm going to do 3, this is 3, and I'm going to put 5 zeros, 1, 2, 3, 4, 5. What that means is the decimal is right behind the 3, and I'm going to move it because of this 5. 1, 2, 3, 4, 5. Now this is different from 3 to the 5ths. It's 3 times 10 to the 5ths. And every time I multiply something by 10 or 100, I just count how many zeros and put it. So I'm applying the same rules as you've learned. So my answer, after you guys 1, 2, 3, 300,000. Okay? This is the same thing. I'm moving it 4. So 4, 3, 9, 5. The decimal is here. So I want to move it 1, 2, 3, 4 times. Because there's no number here, and I need to move 4, that's when I add that 0. Okay? So my answer then is 43,950. The next one, I have 6.79, and I need to move it negative 6, so I'm moving it to the left. So it's going to be a smaller number. I'll move it 6 times. So I'm going to go 1, 2, 3, 4, 5, 6. So that means I have to add 5 zeros. So this is my number. 5. Okay? Do you get that point? All right, so the next one, they want us to write in scientific notation. So I'm going to work backwards. I'm going to make it look like this. So I'm going to put here as 8, right, times, well, if I put the decimal here, 1, 2, 3, 4, 5. So times 10 to the 5th power. Okay? The next one here, I have 64, so I'm going to put the decimal between 6.4. I mean between the 6 and the 4, because it needs to be right behind that first number. So 6.4, and then I'm going to move it 1, 2, 3, 4. I moved it from here 1, 2, 3, 4 times, because I want to put it 6, 4. So it's times 10 to the 4th. The last one, I'm going to put it 1.19. So I want to put it right here, right behind the first number, and that's a non-zero. So that means I moved it 1 to opposite. So it's getting smaller, so I do times negative 2. All right? So go ahead and try page 509, number 3, 4, and 6. 509, numbers 3, 4, and 6, and I will see you in class.